Let's just take some examples now from the chapter and see how we would handle each of them. The first one is the integral from 0 to 2 of cosine pi x e to the sine pi x dx. Well, we probably want to let u be the exponent, sine pi x. So we'll say u equals sine of pi x. Then the derivative of sine of pi x is cosine of pi x times the derivative of pi x, which is pi. That gives us du over pi is the cosine of pi x dx. When x is 0, pi times 0 is 0, sine of 0 is 0, so x equals 0 implies u is 0. When x equals 2, we have sine of 2 pi, and u is again 0. Well, here's an interesting situation. I don't even have to do any more work. We certainly could plug these in and find out, but what do we have? We have the integral from 0 to 0 of 1 over pi times e to the u du. What's the integral from 0 to 0 of anything? It's going to be 0. So because we could make the full substitution, when we change the limits, we find out that we really don't have to evaluate the situation at all. We simply end up with 0 for our answer. How could that happen here? Well, it must be the case that the amount above the axis is equal to the amount below the axis. This is always positive, so what we're really looking at is where is cosine positive and where is cosine negative. Okay, let's take another example. Here, we want u to be the square root of x, or x to the 1/2. So we've got the integral of tangent square root of x over square root of x dx. We'll let u equal x to the 1/2, and then we take the derivative. Du dx is 1/2 x to the minus 1/2. Or du over 2 is dx over the square root of x. X to the minus 1/2 is 1 over the square root of x. So taking the negative exponent puts it down there. There's our dx over the square root of x. So this is 1/2 the integral of the tangent of u du. That's 1/2, and now we know the integral of tangent is the natural log of the absolute value of the secant of u plus a constant, and u was the square root of x. So this is 1/2 times the natural log of the absolute value of the secant of the square root of x plus a constant. Okay, here's a simple example that we couldn't do before this chapter. We knew how to break this up. We can think of this as the integral from 1 to 2, and then rewrite this whole thing in powers of x. X cubed over x squared is x. X over x squared is minus x to the minus 1, and then 2 over x squared is plus 2x to the minus 2 dx. In this case and in this case, we can use the powers rule. Here we have a logarithm. So this is x squared over 2 minus the natural log of x, absolute value of x technically, but we're all positive here, plus 2 times the x to the minus 2 is x to the minus 1 over minus 1, evaluated from x equals 1 to x equals 2. So this is 4 over 2 minus the natural log of 2 plus, let's see, this is 2 over 2 times negative 1. So this is minus 1. And we do the same thing at 1. Minus 1/2 minus the natural log of 1, which is of course 0, plus 2 over minus 1, which is negative 2. And let's see what we get. We get 2 minus 1 is 1. 1/2 Minus 2 is minus 3 halves, so we get 1 plus 3 halves. I think we get 5 halves minus the natural log of 2. No guarantees on that. Check that for yourself. Let's see. 2 minus 1 is 1, minus a half is 1 half, plus 2, minus a minus, plus 2 is 5 halves. Natural log of 1 is 0. So we get 5 halves minus the natural log of 2, I believe. Contact me if I made a mistake somewhere. It's possible I messed something up here, here, or here. Double check that for me. Thank you.